Hey, I'm Mehreen from DAV Public School, Dayanand Bihar. Welcome to the 12th episode of Itihaas, an initiative by the history students of my school. Today we're going to talk about a study of conservation and restoration of cultural heritage in India with the help of science and technology.
A study of conservation and restoration of cultural heritage in India with the help of science and technology.
Let us look at some fundamental duties of the Indian Constitution. These fundamental duties prescribe the duties and rights of the citizens to the state. Some of these are: abide by the Indian Constitution and respect its ideals and institutions, the national flag and the national anthem. Value and preserve the rich heritage of the country's composite culture. Safeguard public property and to abjure violence. Promote harmony and the spirit of common brotherhood amongst all the people of India, transcending religious, linguistic, and regional or sectional diversities, and to renounce practices derogatory to the dignity of women. Now, why do you think these duties are there in the Constitution? We shall answer this question at the end of this video. Cultural heritage of India. Cultural heritage includes tangible culture such as buildings, monuments, landscapes, books, works of art, and artifacts. Intangible culture such as folklore, traditions, language, and knowledge. And natural heritage including culturally significant landscapes and biodiversity. India is a vast nation with a very rich cultural heritage that is affected not only by religions but also by geography. Every region celebrates a different version of Indian traditions. The majority religion, Hinduism, derives most of its customs from Vedas, which are religious texts originating in ancient India. Other religions like Islam and Christianity came in the Indian subcontinent from foreign influence, like the spread of Islam by Prophet Muhammad in 7th century. With this diverse religious background, the country has numerous festivals, and to top it all, each ethnic group, state, and every community has its own list of festivals. Starting from Eid to Diwali, every religious festivals are not bound to one religion. Every celebration tactics like sharing sweets, greetings, and feasts are performed to bring all religious people together and to spread happiness. These values of cultural heritage are expressed by creating religious sites like temples, mosques, churches, etc. These are some architectural wonders from India: the Taj Mahal, Khajuraho Temple, Mysore Palace, and the Golden Temple. The cultural heritage of India. The Holy Festival, a script from a mythological epic Mahabharata. Some sculptures from Khajuraho Temple. The Mohiniyattam dance. Need for heritage conservation. Heritage conservation is important as it provides a sense of identity and continuity in a fast changing world for future generations. It is done for the identification, recording, analysis, and protection of heritage and cultural resources. Cultural heritage represents the past history and culture of a nation. The buildings constitute together the architectural heritage of an area. Heritage buildings possess historical values resulting from their beautiful architecture and their correlation with important events that occurred in the heritage area, such as religious, social, and political events. Conservation of heritage buildings is an important tool in city development and plays an important role to define the landmark within the heritage area, as well as to generate economic returns and to support the tourism industry. Conservation science. Conservation means all the process of looking after a place so as to retain its cultural significance. It includes maintenance and may, according to circumstances, include preservation, restoration, reconstruction, adaptation, and interpretation and will commonly be a combination of more than one of those. With respect to cultural heritage, conservation science is the interdisciplinary study of conservation of art, architecture, technical art history, and other cultural works through the use of scientific inquiry. General areas of research include the technology and structure of artistic and historic works. In other words, the materials and techniques from which cultural, artistic, and historic objects are made. Conservation science includes aspects of chemistry, physics, and biology, engineering, as well as art history and anthropology. These are three broad categories of conservation science with respect to cultural heritage: understanding the materials and techniques used by artists, study of the causes of deterioration, and improving methods or techniques and materials for examination and treatment. In India, the Archaeological Survey of India (ASI) under the Ministry of Culture is the premier organization for the archaeological researches and protection of the cultural heritage of the nation. It regulates all archaeological activities in the country as per the provisions of the Ancient Monuments and Archaeological Sites and Remains Act of 1958. It also regulates Antiquities and Art Treasure Act of 1972. The organization has a large workforce of trained archaeologists, conservators, epigraphists, architects, and scientists for conducting archaeological research projects. Structural preservation. These are some structural preservation projects undertaken by ASI. Art preservation and sculptural preservation. These are also some projects undertaken by ASI in which images before and after preservation are shown. Some methods of deterioration. Physical forces. They are any interaction with an object that changes its current state of motion. Physical forces can cause a range of damage from small cracks and fissures to complete destruction or disintegration of material. Impact, shock, vibration, pressure, and abrasion are a few examples of physical forces that can have adverse effects on material culture. Physical forces can occur from natural disasters like earthquakes, working forces like handling, cumulative forces like gravity, or low level forces like building vibrations. Fire. Organic materials such as paper, textiles, and wood are especially susceptible to combustion. Inorganic material, while less susceptible, may still suffer damage if exposed to fire for any period of time. The materials used to extinguish fire, such as chemical retardants of water, can also result in further damage to material culture. Deterioration by physical forces and deterioration by fire. Water. It primarily causes physical changes such as warping, stains, discoloration, and other weakenings to both inorganic and organic materials. Water can come from natural sources such as flooding, mechanical and technological failures, or human error. Moisture in the air also directly affects relative humidity, which can turn faster the deterioration. It also supports the growth of mold and chemical reactions. If the water is polluted, both of which can further damage the object. Incorrect temperature. Incorrect temperature can cause varying levels of deterioration for objects. Temperatures that are too high can lead to chemical and physical damage, such as embrittlement, cracking, and fading. Temperatures that are too low can also result in physical damages, such as embrittlement and cracking. Temperature fluctuations can cause materials to expand and contract rapidly, which causes stress to build up within the material and eventual deterioration over time. Deterioration by water and incorrect temperature. Theft and vandalism of the Somnath temple. Theft and vandalism. Theft, the removal of an asset, and vandalism, the deliberate destruction or disfigurement of an asset. are directly controlled and limited by the security measures put in place at a cultural institution. Conservation science can aid in the authentication or identification of stolen objects. In addition, the research of the field can help repair, minimize, or mitigate the damage from vandalism. Pests. Pests include microorganisms, insects, and rodents and are able to disfigure, damage, and destroy material culture. Damage can occur from pests consuming, burrowing into, and excreting on material. Conservation and restoration. The first cycle of conservation is the identification of objects. It involves researchers, historians, conservators, as well as scientists in search for full picture of the object. All these people compile information to create a foundation of knowledge upon which all future care depends. The information gained from these accurate detailed registration can have numerous applications in the conservation process of the object. Contrary to common belief, an archaeologist does not stop searching after a discovery. Once an artifact is discovered, archaeologists try to seek answers for several issues: its origin, settlement, cultural evolution, technological development, social classification, as well as belief. They blend other disciplines like science and technology for this purpose. Some scientific methods for restoration. A CT scan or computer tomography scan. It is an imaging procedure that uses computer processed combinations of many X-ray measurements taken from different angles to produce cross-sectional images of specific areas of a scanned object, allowing the user to see inside the object without cutting. For many fragile objects, direct research and observation can be damaging and can degrade the object over time. Using CT scans, conservators and researchers are able to determine the material composition of objects they are exploring, such as the position of ink along the layers of a scroll without any additional harm. X-ray fluorescence (XRF) spectroscopy uses an X-ray beam on the surface of an object which produces a characteristic fluorescence X-ray of the elements present. A non-destructive technique, it is used in conservation science to identify the elemental and chemical content of the materials present in the examined area. Computed tomography scan or CT scan. XRF spectroscopy. Radiocarbon dating. Radiocarbon dating is a method that provides objective age estimates for carbon-based materials that originated from organic sources, estimated by measuring the amount of carbon-14 present in the sample and comparing this against an internationally used reference standard. Carbon-14 or C14 establishes data on chronologies of glaciations and sedimentation, past sea levels and ancient climates. C14 also tells us about the sources of intensity and man-made pollution of the atmosphere, land, rivers, lakes and oceans, and the periodicity of earthquakes, floods and storminess. GPR or ground penetrating radar. It is a broadband impulsive radar system that has been specifically designed to penetrate earthen materials for the detection of buried objects. Magnetic resonance imaging (MRI). It is a medical imaging technique used in radiology to form pictures of the anatomy and the physiological processes of the body. MRI scanners use strong magnetic fields, magnetic field gradients, and radio waves to generate images of the organs in the body. Radiocarbon dating, ground penetrating radar, and magnetic resonance imaging or MRI. NIPGAT or neutron induced proved gamma ray technique is being used for in situ quantitative determination and analysis of industrial, environmental, and archaeological materials as well as location of contaminants, particularly water and soluble salt in building materials. Compared to conventional methods, this new technique provides an accurate and reliable data as well as offers an excellent level of sensitivity. NDT or non-destructive testing. It has been developed and introduced in conservation and preservation of building materials. NDT methods involve ultrasonic radar thermography, visual experiment, as well as radiography to focus on the roots or sources of decay caused by age, environmental attacks. For instance, detection of corrosion in metal-based objects is one of the NDT methods. NDT also provides several important information on historical objects such as structures, methodologies, and quality of the object itself. Chromatography, a set of laboratory techniques used to separate mixtures of compounds. Several of the techniques are extremely adept in the positive identification of organic materials. There exist different types of chromatography techniques like liquid chromatography mass spectrometry LCMS, gas chromatography mass spectrometry GCMS, etc. Restoration via gas chromatography mass spectrometry NDT or non-destructive testing. Conservation and restoration of Jaisalmer Fort, Rajasthan, India. Jaisalmer Fort is situated in the city Jaisalmer in the Indian state of Rajasthan. It is believed to be one of the very few living forts in the world. Jaisalmer Fort is the second oldest fort in Rajasthan, built in 1156 AD by the Rajput Rawal ruler Jaisal, from whom it derives its name, and stood at the crossroads of important trade routes, including the ancient Silk Road. Unlike most forts, the Jaisalmer fort has been built over a weak sedimentary rock foothill, which makes its foundation especially vulnerable to seepage. The Jaisalmer fort today faces manifold threats that are a result of the increasing population pressure on it. Water seepage, inadequate civil amenities, derelict houses, and seismic activity around the Trikuta hill are some of the major concerns impacting the fort. These are some images of the Jaisalmer fort. The 1999 mission. In December 1999, World Monuments Fund or WMF sent an emergency technical mission to Jaisalmer to gain a comprehensive understanding of issues and to meet with all concerned stakeholders in order to assess the situation. They observed firsthand the detrimental effects that an inadequate drainage system, compounded by increased rainfall due to climatic changes, has had on the structural stability of the fort. Extensive surveys of the fort and observations of ongoing work were carried out by the WMF team. Samples were taken from the fort. A cross section was made to highlight the key areas that needed repairs. Jaisalmer Fort cross section showed the general model of the geological structure and the main structures, the retaining walls, the bastions, the pitching walls, and the buildings. In Jaisalmer, the WMF team had opportunities to meet at length with the collector, public work department engineers, local residents, and ASI engineers. In New Delhi, there were meetings with officials at ASI and INTAC or the Indian National Trust for Architecture and Cultural Heritage. Deterioration and restoration of Jaisalmer Fort. These images are before restoration and after restoration. Over the years, the seepage has led to the collapse of significant portions of the fort, such as the Queen's Palace or Rani Ka Mahal, and parts of the outer boundary wall and the lower pitching walls. Restoration of the Rani Ka Mahal was chosen as WMF's initial project in Jaisalmer. Ahmedabad-based conservation architect Kulbhushan Jain was contracted as project architect and intact to facilitate implementation and provide monitoring. The second phase reconstructed a collapsed facade of the Ranika Mahal and brought this building into active public use as a heritage center. These are some images of the Ranika Mahal. Extensive work was undertaken in three places in the lower pitching of the outer wall of the fort. This work was an almost continuous process which has been undertaken for the last 20 years. Several reports were written over the years to identify problems faced in the fort and perspectives for the future. The most important amongst these has been its wastewater management plan commissioned by the Ministry of Tourism, Government of India. The plan was implemented in principle, but because of government policies of not investing in private housing, the economically challenged sections of the fort residents did not connect to the system. Jaisalmer Heritage Trust was formed in 1999 with the objective of establishing a focus towards sustaining the efforts of multiple agencies working in Jaisalmer. The Jaisalmer Fort has been retained on World Monuments Watch list, a rare three times, and has undergone several restoration projects, with the most recent one in 2016. It still needs some restoration to be done, but the previous projects has made it stronger than ever. Today it stands as proud as it did when it was newly built. How can we contribute to this preservation? The public should be aware about the need for preservation of heritage and can work with the government for its promotion and protection. One such scheme that promotes the protection of cultural heritage is Ek Bharat Shresth Bharat. The initiative was announced by the Honorable Prime Minister of India on 31st October 2015 on the occasion of 140th birth anniversary of Sardar Vallabhbhai Patel. Through this innovative measure, the knowledge of the culture, traditions, and practices of different states and union territories will lead to an enhanced understanding and bonding between the states, thereby strengthening the unity and integrity of India. Objectives of this scheme: celebrate the unity and diversity of our nation and to maintain and strengthen the fabric of traditionally existing emotional bonds between the people of our country, to promote the spirit of national integration through a deep and structured engagement between all Indian states and union territories through a year-long planned engagement between the states, to showcase the rich and cultured custom and traditions of either state for enabling people to understand and appreciate the diversity that is India, thus fostering a sense of common identity, to establish long-term engagements, and to create an environment which promotes learning between states by sharing best practices and experiences. We asked a question in the beginning of this video that why do you think the fundamental duties talk about preservation and protection of our cultural heritage? Well, we saw the need for conservation of our cultural heritage, but now let's talk about how we can conserve it at an individual level. These are some individual level initiatives that we all can take. Do not deface a monument by scratching it with sharp objects or spitting in the premises. Spread awareness amongst your family and friends about the need for preservation of cultural heritage. Avoid taking fuel operated vehicles in the immediate radius of a monument as the gas emissions may damage the premises. Instead, take battery operated vehicles or public transport provided by the government. For example, e vans are available at Taj Mahal. Do not litter the area. Plastic packed food can be avoided wholly.
Hey guys, thank you for watching the video. I'm really glad I got the opportunity to research on this project. I would like to thank my mentor, Mrs. Rashmi Dash, and my classmates for helping me brainstorm some ideas on the individual level efforts that we saw at the end of this video. I hope you liked it. Thank you.